So very short report with lots of illustrations, simple for non-scientists, non-specialists to understand, but at the same time to have it not too much criticism from our scientists, colleagues scientists, which was challenging. So I think the first round was too complicated. So then it was rewritten completely in much simpler words, and it became too simple. So we had lots of criticism from our colleagues that it's too simple, simplicity. So then we start to work on it, and I think it is balanced right now. So it's balanced pretty good. So it's still written in very simple language, however, all mentioning of scientific terminology and generally description of permafrost and changes in permafrost and importance of these changes are pretty scientifically correct. Well, permafrost is any earth material which is at or below 0 degrees Celsius for 2 or more consecutive years. Well, the fact that permafrost contains significant amount of carbon, which is now excluded from carbon cycle because its material is frozen, decomposition rate is minimal. The fact that this amount of carbon in permafrost is significant was known for many years. There is nothing new in this. However, the estimates, more or less, more or less up-to-date estimates were obtained just very recently. It was publication 2009, and then after that several other papers, which really estimated the amount of carbon sequestered in permafrost. And that amount was, and the number was really big. So that's kind of impressed scientific community. And only after that, and it, like again, I said it was in 2008, 2009, this publication. Only after this, the modeling community started kind of pay attention to this fact that this thawing permafrost, which everybody believes will happen if climate will continue to warm. It's just physically based process, and there's no surprises. But the effect of this thawing permafrost on carbon cycle, the importance of this effect was recognized only recently because of the publication of these numbers of how much carbon is sequestered in permafrost. And global climate modelers, of course, they have many other problems. So it's not only this thawing permafrost, carbon from thawing permafrost is not included. There are many other feedbacks which are not included in the models. So they have to develop their priorities. And until very recently, permafrost dynamics was not among these priorities. That's why it was not included so far. But at present, during the last several years, many groups who are involved in this climate models development, they are really pay attention to that, and they're trying to include this carbon and permafrost dynamics in their models. But it's very beginning, and there's many uncertainties so far, and it's very far from something which will produce solid results. This is exactly why it's so worrisome, because we have no control on that. If we have at least theoretical control on emissions from human activities, or at least theoretically we can say we can control this, we can change emission or burning rate of fuel, but and because of that we feel like we can do something to change it if it will be necessary. In case of thawing permafrost, if permafrost is thawing because of warmer climate, there is no way to control it or to stop it, to prevent it. If climate will be warm enough for permafrost start to thaw very widespreadly, so then there is no control. It just will go by itself. So far, this permafrost monitoring network is mostly scientific based. So most of the data what we are collecting are coming from scientific projects which funded by national funding agencies. In the United States it's mostly National Science Foundation, but not only. USGS fund similar kind of research, and other countries also mostly funded through scientific projects, which are usually very short-termed, 3 years, maximum 5 years. So the system or network of permafrost observatories which we developed is pretty impressive. It's still very far from ideal. It will not be ideal, of course, but there's big gaps, especially in Siberia, also central Canada. Big gaps in observational stations. However, it is producing some results which are allowed us to say what permafrost is doing globally. But the problem is this kind of scientifically based network is its sustainability, how to sustain these measurements. Because if this scientific project runs out of money and no new project will be funded, so we'll have gap in data because no agency is responsible for that. So the idea is to make national governments kind of feel responsible to sustain, to maintain these networks somehow. Well, of course, first it's funding, but it's not only funding. It's also infrastructure needs to be developed. Some kind of similar to what is weather service, for example. So there's weather stations which are maintained by governmental agencies. So probably it is possible to do something like this for permafrost monitoring as well. Yeah, of course. In Alaska, people live with permafrost, or sometimes on permafrost, for those unlucky ones. And in some locations, like in Anchorage, it's just few patches of permafrost. So mostly it's no permafrost. There is not such a problem. In Fairbanks, it's already kind of at least half and half, maybe more half, on permafrost. So it's already more problem. And for buildings, for roads, especially for any kind of infrastructure. And if you move further north or northwest, there are some villages which are suffering from degradation of permafrost right now. There is some discussion about relocation of these villages, and it's not only because of this coastal erosion, the ocean coast or river banks erosion, but even in settlements like Selawik, for example, which is not on the coast, there is some big problem with thawing permafrost and affecting whole infrastructure of the village. So, the people who live there are definitely concerned, and it's probably getting the largest concern right now, what will happen to in these areas. Now, government, of course, also there is concern about it as well. So I would say there is lots of work needs to be done, and the major thing is that what we see right now it is just the beginning. So what people experiencing right now and saying, oh, how bad it is. So it will be much worse soon. So that's the problem. Well, all depends, of course, on rate of changes in climate. And what we know about it now is mostly based on these climate models, projections. And those projections are saying that the major acceleration of warming will probably happen sometimes in 20-30 years. So it will be still warming up to that time, but on a less degree, and rate of warming will be relatively small. However, even this small rate will already impact permafrost in many locations. But probably the major changes, if we trust these projections, will happen sometimes in 2040, 35, somewhere there. But it's all based on these projections, which are not perfect, of course. Trust these projections will happen sometimes in 2040, 35, somewhere there. But it's all based on these projections, which are not perfect, of course. And there's huge uncertainty there. For example, with sea ice projections were that decrease in sea ice was projected, of course, but not in that rate which we are seeing it right now. So what is happening right now, it's much faster than it was projected. So the same could happen with permafrost as well. But at least on the basis of what we know now, I think we still have maybe 10, 15, 20 years to address these questions, maybe. Changing in permafrost will change surface conditions. For example, forests can turn into swamps and bogs, or it could be actually turn into much drier conditions as well, depending on settings, kind of environmental settings. Lakes can grow in the north but disappear in the south. And actually the rate of changes now in lakes shows that even within the continuous colder conditions, mostly lakes are disappearing right now. So changes of these environmental conditions for wildlife will be very significant. And of course there will be some winners and losers. Of course, ecosystem is more adaptive than infrastructure, I would guess. So probably ecosystem will adapt more smoothly. However, again, there will be some losers, and some species could be suffering from these changes. And some of them maybe will welcome all these changes. So, but it will be different. It will be different, and the uncertainty of what it will be is huge again. That's why there's lots of efforts right now to understand what changes in permafrost, how they will affect ecosystem, how they will affect vegetation, how they will affect this species composition, and how they will how it will affect animals, and some of them very important for humans who live there in Alaska, and not only in Alaska but in the north. So that's big question, and it's scientific question as well. So how we can predict changes in environment and ecosystem because of changes in climate and permafrost. Well, everywhere where permafrost has ice, significant amount of ice, and there's big regions in Alaska where permafrost is very icy. Of course, there is some more stable permafrost with colder conditions, like on the North Slope, and changes there will be probably more gradual right now and not so immediate. However, there is some regions, especially in the northwest of Alaska, where permafrost temperature is very, very warm now, close to freezing point, but at the same time there is lots of ice still in permafrost. And I already mentioned this Selavik village, but it's just one example. It's all this northwest corner of Alaska is very close to big changes, and I think that's one of the hot spot where we should pay a very serious attention what is going on there.